Hello there, Mr. Sutton here, bringing you the AB Calculus 5-2 Extra Practice Number 2 solutions on Antiderivatives Part 2. To find the antiderivative of this rational expression, it'll be easier if we divide everything in the numerator by the denominator to simplify this first. So going from left to right, this is going to be negative 8 times x to the negative third power plus 16 times x to the negative 5. And now let's just use the reverse power rule. So this first exponent's going to bump up to a negative 2. Dividing by that, we're going to have 4x to the negative 2. And over here, this bumps up to a negative 4. Dividing by negative 4, we have minus 4x to the negative 4. And then don't forget the plus c. On this one, we can use the antiderivative rule for cosecant cotan, which is going to be a negative cosecant. However, we do have this interlinear function, so we're going to have to reverse the chain rule by dividing by the derivative of the stuff in here. So that's going to be a negative 2 we're dividing by. So let's see here. We end up with a negative 4 cosecant cotan of this stuff initially, but we're dividing by negative 2. So when all is said and done, to go with our cosecant of 2 minus 2x, we're also going to have a positive 2 out there because we initially had a negative of 4 and we're dividing by a negative 2. And then don't forget the plus c. To take the antiderivative of this expression, I'm going to rely on the fact that cosecant is really the reciprocal of sine of x, so I can rewrite this as negative 3 sine of x, which is a whole lot easier to deal with. And now taking the antiderivative of this, well, antiderivative of sine is normally negative cosine, but that's going to cancel out the negative that's already out there, and this 3's along for the ride. So we're going to end up with positive 3 cosine of x plus c. For this one, looks kind of like a mess here. I'm going to start by trying to simplify this trig expression. So to do that, I notice that I have 2 of these cosines in the denominator. So I'm actually going to split up this fraction. I'm going to write this as negative 5 over cosine of x times sine of x over cosine of x. And negative 5 over cosine of x, I can rewrite that as negative 5 secant of x. And then over here, sine over cosine we know is tangent of x. So I know the antiderivative of secant of x, tan of x, is just secant of x. This negative 5 is along for the ride. So we end up with negative 5 secant of x plus c. To deal with this antiderivative, I'm going to rewrite this as negative 3 times secant squared of x, because cosine and secant are reciprocals. I know the antiderivative of secant squared is tan, so this is then going to be negative 3 tan of x plus c. To take this antiderivative, I have to know that the antiderivative of secant squared of x is tan of x, so I'm going to start by writing this as tan of 30x. However, since I have this linear function inside the tan here, I'm actually going to have to divide by 30 to offset the chain rule if I were to take the derivative here. So I'm going to have negative 5 over 30, which is negative 1 over 6. And then we're also going to have a plus c. For this expression, to take the antiderivative, I first need to simplify this. So I can factor the numerator. Things that multiply to negative 20 and add up to negative 1, that would be x plus 4 and x minus 5. Conveniently, those x minus 5s are going to cancel. So we really have the antiderivative of x plus 4 dx. And then just using the reverse power rule, we're going to bump this exponent up to 2, divide by 2, so that's 1/2 x squared, plus reverse line rule here. This is just going to be plus 4x plus c. The easiest way to take this antiderivative is going to be to simplify by distributing this x cubed. So we're going to have 25x to the 4th minus 12x cubed. And now I can just use my reverse power rule. So this first exponent bumps up to 5. Dividing by that, we have 5x to the 5th. And this next exponent here, this is going to become a 4. Dividing by that, we have 3x to the 4th, and we're subtracting that. And then we have our plus c. For this antiderivative, what we basically have here is a 1 over x kind of situation. So we're going to use our ln absolute value antiderivative. So I'm going to write ln absolute value of 8 minus 3x, but there's some other things I'm going to have to do for the coefficient on this one. So initially, I've already got a negative 4. And now, since I have this inner linear function, I have to divide by its derivative, this negative 3 here. So I have negative 4 divided by the negative 3 derivative there. That ends up being 4/3 out in front. And then we have our plus c. For this antiderivative, I'm going to rely on the antiderivative of e to the x rule, which basically is just e to the x. So I'm going to have e to the 1/2 x minus 4. But because I've got all this stuff inside here, and it's a linear inner function, I actually have to divide by the derivative of a linear inner function. So that means I'm really dividing by 1/2 or multiplying by 2, and I already have a negative 1 outside here. That's going to end up being negative 2 then for my coefficient, and don't forget that plus c. For this antiderivative, I know that the antiderivative of cosine is sine, so I can start by writing sine of x over 4, but I have an inner linear function, and I have to divide by the derivative of that to offset the chain rule. So I'm going to be dividing by 1/4. I already have a 3 out in front, so 3 divided by 1/4, that's really 3 times 4, which is 12, and then we have our plus c. For this one, it helps if you recognize that this is kind of like 1 over the square root of 1 minus x squared, whose antiderivative would be arcsine, but we're not quite in that form. We have to get it in 1 minus something squared form first. So to do that, I'm going to start by factoring out a 36 inside this radical. So that gives me 36 parentheses 1 minus 1 over 36 x squared. And on my next step, I'm actually going to do two things here. First thing I'm going to do, I'm going to square root this 36 and bring it outside the integral. And now inside this radical, I'm just going to rewrite this 1 over 36 x squared as 1 over 6x, the whole thing in a parentheses, like this. Because I really need this 1 minus something squared format in order to use my arcsine antiderivative. But now that I've got that, this is essentially going to be arcsine of 1 over 6x. But since I have this inner linear function, I'm going to have to divide by the derivative of this, which means multiplying actually by 6. Since I already have a 1 over 6 out in front, that's going to cancel out, just leaving me with arcsine of 1 over 6x plus c. On this problem, I'm just trying to take the antiderivative of x squared over 4 dx. So for this one, I can actually just use my reverse power rule. The exponent's going to bump up to a 3, and then we're going to divide by that. So 1/4 divided by 3 ends up being really just 1/4 times 1/3, which is 1/12. Again, we have x to the 3rd, and don't forget the plus c after that. So that ends up being choice B. For this antiderivative, it's a little tricky at first glance here. I mean, one thing we could do if we wanted to is factor a negative 1 out of the denominator. That would leave us with x squared minus 6x plus 10. So maybe that's not a bad first step. But, you know, then where do you go from there? So this one right here, choice A, ln absolute value of all that stuff, if you actually try taking the derivative of that, you're going to see that you end up with like a negative 2x plus 6 in the numerator, which is not going to reduce to this. So choice A can definitely be eliminated. Probably the easiest way to do this is to just take the derivatives of all these answer choices until you get something close to what you started with. But even then, I mean, you're not getting this x squared plus 6x minus 10 if you're dealing with any of these x minus 3s or x plus 3s. So another tactic to take, I mean, we see that these are all tan inverse, so maybe there's something going on with this tan inverse idea. If we can get this denominator to be in the format of something squared plus 1, which is kind of our arctan derivative format, then maybe we have a fighting chance on this one. So this is one of those where if you've done a few of them, then you know to look out for it, but otherwise it's kind of hard to see what you need to do. What we're going to do here is we're going to take this 10, and we're actually going to split it up. X squared minus 6x plus 10 is almost a perfect square trinomial. If this were x squared minus 6x plus 9, then we'd be in business. So what I'm going to do is I'm going to split up this 10 into a 9 plus 1. And here's what that allows me to do. X squared minus 6x plus 9, that trinomial right there is actually a perfect square. This is really x minus 3 times x minus 3, or x minus 3 quantity squared. And we just have this plus 1 kind of along for the ride, but even this plus 1 is helpful in this problem, because if you have 1 over something squared plus 1, that is, the antiderivative of that is going to be arctan of the something. You're also going to have to divide by a inner tail if there is one, but here the inner derivative is just like a 1, so we don't even have to worry about that. So then this just ends up being negative arctan of x minus 3 plus c, and let's see here, that's going to end up being answer choice B.